Let's look at lesson 50, the geometric mean. Well, what does geometric mean mean? Well, I'm going to skip ahead to example 3, and I'm just going to show you what geometric mean is. If it says find the geometric mean between 3 and 12, well, what that means, we're going to set up kind of a, not a proportion, but two fractions here. And I'm going to actually put 3 and 12 on opposite spots, diagonal from each other. In the other blank, I will put my variable. So x is the geometric mean here. So x is the geometric mean in both of them. The book gives the example of a over x equals x over b, and that's what we've done here. We've just used our numbers. And then from here we solve. 3 times 12 is 36 by cross multiplying, and then we do x times x, and that's x squared. From here we can square root and find that 6 is our geometric mean. Notice that 6 is not exactly between 3 and 12, but that's okay. That's what the geometric mean is. If we were finding the geometric mean between 2 and 9, all right, 2 and 9, we would set it up the same way. 2 over x equals x over 9, because we are when we have products, or what we multiply, we should have our geometric mean being multiplied by itself. So x squared equals 18, so square root of 18 would be its geometric mean. So that's how you do the geometric mean, and that's what its definition is. Now let's look at a couple of examples that use shapes. Now before I start on example 4, I'm going to read, this is actually called Corollary 51.1. We don't really use that word as much, but the definition is going to show you how to solve for these. What it says is, if the altitude is drawn to the hypotenuse of a right triangle, then the length of the altitude is the geometric mean, that's key, between the segments of the hypotenuse. So right here we have our right triangle, or whatever. And it says if the altitude is drawn to the hypotenuse. So what we have here is, this is actually our hypotenuse. This whole shape is not a right triangle, but TV is the altitude, line TV. And so therefore, since it's the altitude, line TV is going to be the geometric mean between segments of the hypotenuse. Here's our hypotenuse. This is what the book is saying. It doesn't really look like the hypotenuse, that's why it's kind of confusing, but it says side SU is the hypotenuse, so we're just kind of going with it. So geometric mean between these two segments of the hypotenuse is y. So how we plug that in is, we're going to set the y's opposite of each other, and then the two segments we have are 3 and 4 over 3. So now we have, if we read this, y is the geometric mean between 3 and 4 over 3. Then we cross multiply. Y squared equals 3 times 4 over 3. 3 times 4 over 3. We've done a little so you can see. The 3's would cross out. Y squared would equal 4. So therefore, y equals 2. Square root of 4 is 2. And that's how you do that corollary. Let's look at one more. This one is corollary 50-1-2. And it states that if the altitude is drawn to the hypotenuse of a right triangle, then the length of a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is closer to that leg. That can be confusing just to read. So let's try to show what that means. Okay, what it states here is the length of a leg is a geometric mean. Length of a leg is geometric mean first. So I circled one leg. We're looking at this overall triangle here, triangle OJN. Its legs are OJ being 3 and JN being 4. So either of these could be a geometric mean for different variables, but I'm going to first look at the 3. This is our geometric mean because it's the length of a leg. Now what is it the geometric mean between? Well, it's between the hypotenuse. Okay, what's our hypotenuse? Our hypotenuse is 5. So 3 is the geometric mean. So we can go ahead and stack it like that between 5 and what the length of the hypotenuse that is closer to that leg. So here's our hypotenuse. And it says length of the leg that is length of the segment of the hypotenuse that is closer to that leg. So here's the two segments. That segment and this segment. Well, which of those two is closer to this leg? A. So therefore, 3 is the geometric mean between A and 5. And now we can solve. 3 times 3, 9 equals 5A. Divide by 5. 9 over 5 equals A. And that's how you do the geometric mean there. Now let's do, so I kind of tried to color code that, draw that out as best I could. Now let's do solve for B. Okay, we already did this one. So now we're going to use 4. 4 is the length of the leg, so therefore 4 is a geometric mean. So we set them diagonal to each other. What's it the geometric mean between? Between the hypotenuse is 5, and the segment of the hypotenuse closer to that leg, so B. And now we can solve. 4 times 4 is 16 equals 5B. Divide by 5, 16 over 5 equals B. So that's what the geometric mean is, and that's how you solve for these different equations using, or these different problems using the geometric mean.